fellow students, welcome back to Algebra 1B. Today we're going to get ready for our summative performance task for Unit 8, Graphing Quadratic Equations. And today we're going to introduce an equation that's going to come up a lot in future chapters, and that is the objects affected by gravity formula. So, any object that is affected by gravity can be shown with the following equation. H of t is equal to negative 1/2 g t squared plus v0 t plus h0. Now, this formula can be a little intimidating at first, but don't worry, it's actually a lot simpler than it looks. So let's talk about what each of these things means to start off with. Now, h of t means the height of the object after t seconds. So, obviously then, t stands for the number of seconds after the object is thrown or dropped or whatever happens. Now, g is the constant of gravity. Now, since all of our activities for this class will take place on the planet Earth, the constant of gravity is 32 feet per second. And for this activity, all of our units will be measured in feet. Just for the science brain out there, 9.8 meters per second is if we were using the metric system. Now, V0 just means the initial velocity or the starting speed. And then H0 means the initial height, just the starting height. Now, since all of our activities will take place on the planet Earth and be measured in feet, we can go ahead and substitute in this 32 feet per second, which is going to give us the simplified equation. H of t is equal to negative 1/2 32 t squared plus VOT plus HO, and that's going to simplify to negative 16 t squared plus VOT plus HO. Now, hopefully what you recognize is that this is a slightly fancier version of standard form that we've talked about before. Standard form of a quadratic function is y equals ax squared plus bx plus c. So you see in this case, a is negative 16, b is the starting speed, and c is the starting height. So for Unit 8, Graphing Quadratic Functions, let's look at a sample problem of this. You throw a rock from an initial height of 5 feet with an initial velocity of 25 feet per second. What is the maximum height that it will reach? So, just drawing a picture of this, if you are here and you are throwing a rock, you're going to throw it up and then it's going to fall down. You're throwing it from an initial height of 5 feet, so that means right here where your hand is 5 feet above the ground. And then it's going to go up, and then it's going to fall down. So the question is, what's the maximum height? That would be right here. So, a key point that we should recognize is that the maximum height is going to take place at the vertex. And the vertex always takes place on an invisible line right here that we call the axis of symmetry. So let's go ahead and set up the equation. The height after t seconds is equal to negative 16t squared plus v0t plus h0. Filling in some of those values, h of t is equal to negative 16t squared. I know that the starting speed is 25 feet per second, so plus 25t plus I know that the starting height is 5. Now I have my equation in standard form. In order to find the vertex, I first need to find the axis of symmetry, and we remember that we have a formula. The axis of symmetry is x, or in our case t, equals negative b over 2a. So in our case, we would say t is equal to negative 25 over 2 times negative 16. Using my calculator to do this calculation, I can do negative 25 divided by 2 times negative 16 is equal to 0.7813. T is equal to 0.7813. Now it's very important to realize what it is we just solved. So T stands for time. It's the number of seconds since it was launched. The axis of symmetry is the middle of the parabola, which is the highest point of the parabola. So that means that the rock will reach its highest point after 0.7813 seconds. I'm just going to write that out. The rock reaches the highest point after 0.7813 seconds. Now, I know when it reaches the highest point, but I need to know what the highest point is. So now all I need to do is take this 0.7813 seconds and plug it into my equation up here. So I can say the height after 0.7813 seconds is equal to negative 16 times 0.7813 squared plus, I need to put multiplication in here because OneNote doesn't do it automatically. 25 times 0.7813 plus 5. And that is equal to 14.7656. And again, it's very important that we realize what this is. So in terms of our problem, the y-axis here would be feet. So answering in words, the maximum height is 14.7656 feet, and it will be reached at 0.7813 seconds. And of course, at this point, if you had been given any instructions on what to round to, we would round appropriately. But that is how we find maximum height when given this information. Let's try a different type of problem. You launch a rock from the ground. So in this case, launch a rock from the ground. It lands 3 seconds later. So in this case, picture some way of launching a rock from the ground. You could either be lying down on the ground and then you throw it straight in the air, or maybe you've got some kind of launching device like a teeter-totter, or you dig a hole and pack some explosives in there. In any case, the rock is on the ground, you launch it, and it lands 3 seconds later. What was the maximum height it reached, and what was the initial velocity? Now, it seems like we might not have enough information to solve this, but one of the key pieces of information that we said at the beginning was that this takes place on the planet Earth. So, since we're on Earth, that means gravity is constant. So that means whatever parabola I get, the a value is going to equal -16. And that's a very key fact for solving this. So here's the other thing. I know that it's going to land on the ground 3 seconds later. So that means I actually know two things. The rock was on the ground at 0 seconds and 3 seconds. So if I just draw a picture of this, this is time. At 0 seconds and at 3 seconds, the rock is on the ground, right here and right here. And then it jumped up into the air, gravity slowed it down, and then it came back down. So the question is, how high did it go? Well, in this case, since I know when it was on the ground, I would like to use intercept form. So intercept form looks like this. Y equals a, x minus root number 1, x minus root number 2. So remember that the roots are where it hits the x-axis, or in our case, the ground. And the a is the vertical stretch. So we know that it's going to hit the ground at 0 and 3, and our vertical stretch is 16. So we can say y equals -16 because we're on the planet Earth. X minus 0, x minus 3. So the axis of symmetry is directly in between these 2 points, right here. And the vertex is on the axis of symmetry. Now, a lot of us can look at this 0 and 3 and say, oh, obviously this is 1.5 seconds. But in a more complicated case, what we would do is take the average of the two roots. So we would say, okay, I've got 0, and then I'm going to add 3 to it, and then I'm going to take the average by dividing by 2. So I get 3 over 2, or 1.5. And this is seconds. So it's going to reach its highest point at 1.5 seconds. So in order to figure out what the highest point is, I'm just going to plug that into my equation. So I can say that it is -16 times 1.5 minus 0. That's a little bit unnecessary, but that's okay. Times 1.5 minus 3. 36. So that means that after you launch the rock, it will reach its maximum height after 1.5 seconds, and it will reach a maximum height of 36 feet. Rock will reach a maximum height of 36 feet after 1.5 seconds. Now, the follow-up question to this was, what was the initial velocity? So, in order to find the initial velocity, I have to get this equation back into this form right here so I can see what the initial velocity is. And that's simple enough because all I have to do is sum multiplication. So I've got y is equal to negative 16 x minus 0 x minus 3. And I'm just going to multiply those. So I have these two binomials here. So I could put x minus 0 and x minus 3. This is x squared. This is 0x, negative 3x, and 0, giving me x squared plus 0x minus 3x plus 0. And simplifying that just turns it into x squared minus 3x. So I get negative 16 times x squared minus 3x. And then I'm just going to distribute the negative 16. Gives me negative 16x squared plus 48x. I put y equals there. So it would actually be h of t is equal to negative 16t squared, because we're using time seconds, plus 48t. And then we could also put a plus 0 at the end. There's an invisible 0 there, and the reason that's nice to see there is because this represents the height, this represents gravity, and then the one piece that we're looking for is this is the initial velocity. So I can now say that the initial velocity of the rock was 48 feet per second.